This is 8.4, the binomial theorem. In today's lesson, you will use Pascal's triangle to calculate the binomial coefficients, use the binomial coefficients to write the binomial expansions, and find the indicated term of a binomial, and find the coefficient of the indicated term of a binomial. Let's get started here. First thing we need to talk about is the binomial expansion. What that means is we're going to have these binomials and we're going to expand them with a certain exponent, or actually like foiling them all out. You know how to FOIL this out. This would be x squared plus 2xy plus y squared, and this would just be 1, right? And this would just be x plus y, and this would be x squared plus 2xy plus y squared. And then we multiply this with another x plus y, and we get x cubed plus 3x squared y plus 3xy squared plus y cubed, and so on. So they can get pretty long, but you notice that for whatever the exponent is, there's always going to be one more term. This is just 1, but this is 1, it has 2 terms. This is squared, has 3 terms. And for 3, there's going to be 4 terms. With exponent of 4, there'll be 5 terms, and so on. If you're looking at just a number in front of the variables, like a 1 and a 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, you notice that those are numbers in the Pascal's triangle. Okay, in case you forgot what the Pascal's triangle is, we'll go over that in a second. But this is the theorem. Okay, this looks pretty ugly, and we actually will have to use it like this, so you should write that down. And I'll show you some tricks on setting this up, writing it out. Alright, so these numbers in front of each one of these terms is called the binomial coefficient. Coefficient is just the number in front of the variables. Okay, so the binomial coefficient is all of these coefficients that came from this binomial. And you can find that by using this combination formula. We're probably not going to use this too much because we have other ways of finding it. One way is to use Pascal's triangle, and Pascal's triangle is we start with 1s on the edge, and then the 1 below it is just the addition of the 2 above it. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, and 3 plus 3 is 6, and so on. And you get this pattern that's always symmetrical down the middle. So you have 1, 1 on each end, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So it's always mirrored image, and it always has a 1 in front, 1 on the other end. What number would go down here? What would be the next row of numbers be? Well, it should always start with a 1, 5, 10, 5, 1. Okay, that would be the next row, so on. And I gave you a copy of the Pascal's triangle that looks like this. And you notice that it's symmetrical about the middle, and it's 1 plus 4 is 5, and 1 plus 6 is 7, and 6 plus 15 is 21, and 15 plus 20 is 36, and 35 plus 35 is 70. And how we're going to use this to find our binomial coefficient is the n represents the rows, the r's are the diagonals. So if I asked you to find 5C2, or the combination of 5 things taken 2 at a time, that's when we're doing probability. If you have like 5 objects and you can select 2 of them at a time, how many ways can you choose that? Well, the rows is 5. You come over here and you look at the row 5 and the diagonal of 2, and they intersect at 10. The row is the fifth row and the second diagonal, and they cross at the 10. So there's 10 ways to choose 2 things out of 5. Okay, so we read this as 5, choose 2. That equals 10. How about 4 things, choose 3. So 4C3. 4C3 would be 4. And how about 7C1? 7C1. 7. And what about 6Z0? 6Z0. Anything 0 is always going to be 1. And anything C1 is always going to be that number. Okay. On your calculator on the TI, it's 5 math, arrow over 3 times 2, and then you're going to put the last number 5C2. On the Prism, you go 5, option, F6, F3, and then your 2. So these are different ways you're going to see the same thing. The binomial coefficient can be written this way, can be written this way, or this way. 9 things, choose 2. That would be 36. 11, choose 4. It's 330. 5, choose 5. How many ways are there to have 5 things and you have to choose 5? If I have 5 different pieces of candy and I said you can have 5 different types of candy, how many ways can you choose that? There's only one way. Expand the binomial. Okay, when we're expanding a binomial, we're going to do this little formula that I have here, and this is the long one, so pay attention, and I'll have you do one after this. So you look at the exponent, that's going to be your n, and there are always going to be one more term than there are n. So if the n is 3, there are going to be 4 terms. And each term is always going to look like this. C, that's the binomial coefficient, x, y. You leave a blank for the exponents and leave a number for the front of the coefficient and the one after. And so we have 4 terms, we're going to make this 4 times. And since n is 3, we're going to put a 3 in front of all the c's. Okay. Then behind the C, we're going to have 0, 1, 2, and 3. We shouldn't see any numbers in this expansion that are larger than 3. So if we have 3, we're going to 0, 1, 2, and 3. If you end up with a 4, if you accidentally started with a 1 here, you put 3, 1, 3, 2, 3, 3, and then you end up with 3, 4, whoop, then you know you made a mistake. Start from 0, 1, 2, and 3. Then you're going to do the same thing with the x's. You can go 3, 2, 1, 0. Then go backwards, 3, 2, 1, 0. And that's how you can end up with all your terms and all the numbers in the right place. Now, we're going to have to convert these all to the binomial coefficients. 3C0 is 1. And x to the third power is x to the third. Y to the 0 is 1. 3C1 is 3. X squared. Y to the 1. Plus 3C2 is 3. X times y squared. Times 3, or plus 3C3 is 1. X to the 0 is 1. And y cubed. Okay, now simplifying this, cleaning this up a little bit. We have x cubed plus 3x squared y plus 3xy squared plus y cubed. Alright, let me walk through that one more time, okay, so that you can make sure you understand. So we start with this here, that's my n, and there's going to be 4 terms, and we're going to go c xy plus cxy plus cxy plus cxy. And then we have 3, 3, 3, 3, and 0, 1, 2, and 3. And then for the coefficient up here, we're going to have 3, 2, 1, 0, and then going backwards, 3, 2, 1, 0. And then you're going to just do the coefficients and then simplify. And things you need to double check is all the two exponents have to add up to n. So you have 3 plus 0, 2 plus 1, 1 plus 2, 0 plus 3. All those have to add up to 3. And another thing, and you can get these from the Pascal's triangle to get your binomial coefficient, or you can use your calculator. Okay, but you should know that anything with a 0 in the back is just 1. Anything with a 1 in the back is just that number. So 4C1 is 4, 10C1 is 10, and 10C0 is 1. Okay. And then because these coefficients come from Pascal's triangle, they have to be symmetrical. So it starts with a 1, ends with a 1, right? In Pascal's triangle, all starts with 1, ends with a 1. And then they're symmetrical about the middle. These may not be down here, but these are always symmetrical. The coefficients, the binomial coefficients are always symmetrical. These coefficients may not be. Here's another one. Okay, so you try to do this one. Pause this if you need to, but you're going to write this all out. Okay, so we start with a 4. So n is 4. That means there are 5 terms. You're going to write this out like this: 5 terms. Okay, and then this is going to be 2x and a negative y, 2x negative y, 2x negative y, 2x negative y, 2x negative y. That's what these two are. Then you're going to put a 4 in front of each one of these c's. And then you can come back and put 0, 1, 2, 3, 4. Then come over here and put a 4, 3, 2, 1, 0. 4, 3, 2, 1, 0. Since n is 4, at no time are we allowed to use any number larger than 4 anywhere in the expansion. Okay, now you're going to use the Pascal's triangle or your calculator, and you know that 4C0 or anything C0 is 1, and anything to the 0 power is 1, and 4C1 is just 4, and so on. So here we going to write this out. 2x to the 4th power is 16x to the 4th power. This is a 4. 2x to the 3rd is 8x to the 3rd. And negative y to the 1 is negative y. 4c2 is 6. 2x squared is 4x squared. Negative y squared is positive y squared. And 4c3 is 4. 2x to the 1. Negative y cubed is negative y cubed, and 4c4 is 1, 2x to the 0 power is 1, and negative y to the 4th is positive y to the 4th. Cleaning this all up, we have 1 times 1 times 16 is 16x to the 4th, 4 times 8 times negative 1 is negative 32x cubed y, 6 times 4 is 24, x squared y squared, 4 times 2 times negative 1 is negative 8xy cubed, and 1 times y to the 4th is y to the 4th. Okay, check to make sure all your exponents add up to 4. Check to make sure that when you have a negative in here, the signs must alternate: positive, negative, positive, negative, positive, negative. Check that your binomial coefficients in this row are symmetrical. 1, 1, 4, 4, 6. Now after you do your simplification, this row may not be symmetrical, but the row up here should be symmetrical. Okay. So one more time. Expand this one to the 3rd power. Pause it, and then after you've done it, check your work. So we have a 3, n is 3, so there are 4 terms. So I'm going to write it out like this: negative x and a 2y, negative x, 2y, negative x, 2y, negative x, 2y. Now this is going to be 3, 3, 3, 3, 0, 1, 2, 3, 3, 3, 2, 1, 0, 3, 2, 1, 0, going backwards. Now the coefficients will be 1, 3, 3, 1. And just cleaning this all up. We have this. Remember that the negative squared is positive. Don't forget to square the 2 here and make 4y squared. And cube the 2 and make 8y cubed. And then simplifying, we should have this. Because we started with a negative x and a positive y, we're going to alternate signs with a negative first. Positive, negative, positive. Check that. Check the exponents all add up to 3. And check to make sure that these are symmetrical about the middle. 1, 1, 3, 3. And then this is your final answer down here. All right. Try this one. I'm not going to work this one out, but you should be able to do this one pretty easily. Make sure you can do that and then check your work. Here's the answer. Next, do that one. I'm not going to work that one out either. You need the practice, and that's the answer. And now we're going to just find a particular term. We're not going to find the whole thing, but let's say I have this binomial that I want to expand, and it's really huge. It's like to the 12th power or something, and I want to find the 8th one. Well, I don't have to write out all 13 terms, so I'm just going to write the 1. So I'm going to use this formula here. It's NCR x the n minus r y to the r. This comes from the fact that this is n minus r. If you look back at these expansions, let me use this example here. If this is r, this is 2, and this is 2, then this is going to be n minus r, or 4 minus 2, give me this 2. This is 3, this is 3. This is going to be 4 minus 3 is 1. This is 4 and that is 4. This is going to be 4 minus 4 is 0. So that's where this formula comes from. Okay, so here we go. So this is going to be r, r, and n minus r here, because these two have to add up to n, right? So n minus r plus r has to add up to n because the r's cancel, if that helps. And r is going to be the term that you're going to need to find minus 1. If you're going to find the 8th term, it'll be 8 minus 1, r will be 7. So the term you're going to have to find is always 1 less than r, or r is going to be 1 less than the term that you're trying to find. I think I said that a little bit wrong. Okay. If that is difficult for you to remember, I came up with this little Ira and Robert. They're brothers, and Ira's 1 year older than Robert. If that helps you, R is going to be 1 less than Ira. So if Ira's 10, Robert's 9. So 9 is equal to 10 minus 1. Okay, or 12. If Ira's 12, then this would be 11 is equal to 12 minus 1. Okay. So let's see this in action here. What do I really mean to find the ith term? Find the third term. So this is the I. Okay, this is I. So find the third term. We know the n is 4. And we know I is 3, which makes R. R is 1 less than I, which R is 2. Now we have everything to put in here. So we know it's going to be 4c2 x to the 2 r to the 2. And x is 2x and y is negative 3. So now we have 4c2 x squared y squared. And double check your exponents. They add up to n. And this is 4c2, and x is 2x, and y is negative 3. Square both of these, and 4c2 is 6. 2x squared is 4x squared. Negative 3 squared is 9. So 4 times 6 times 9 is 216x squared. Let's do another one. Find the second term for this binomial. So n is 6. I is 2, which makes r 1. Putting all of this together, we get 6c1, x to the 5th, y to the 1. And since this is x and y, and they're both positive, there's nothing to do here. Double check my exponents, make 6. And we have 6c1. 6c1 we know is 6. So the answer is 6x to the 5th, y to the 1. Okay, find the sixth term. See if you work this one all the way through. Pause it, and then when you're done, check your work. Okay, I'm going to do this one now. N is 8. I is 6. R is 5. Putting this all together, I have 8, C5, x to the 3rd, y to the 5th, and x is A, y is 2b. So I'm going to do that. Double check my exponents. I did that correctly. That's 8. This is 8c5, and a to the 3rd, b, 2b to the 5th. Okay, so 8c5 is 56, a to the 3rd, and 2 to the 6th to the 5th, 2b to the 5th is 32b to the 5th. Multiplying the 32 and the 56, I get 1792 a to the 5th, a to the 3rd, b to the 5th. Here's something a little different. I want to find the number in front of the term that has a to the 4th and b to the 7th in it when I'm expanding this. So this is kind of tricky. This kind of goes backwards. There would be like this last problem where I said, well, if a to the 3rd and b to the 5th, what is this number in front? So I'm looking for this number for this binomial expansion. So I want this binomial expansion, and I want the term, the number that goes in front of a to the 4th, b to the 7th. Well, how do I do that? I know that r is going to be 7, and I know that n is 11, and 11 minus 7 is going to be 4. So I'm going to write this out like this. N is 11, r is 7. I'm going to put all this together like this. 11c7, x to the 4th, y to the 7th. Replacing my x with 2a and y with 3b, negative 3b. I get this. 11c7 is 330. 2a to the 4th is 16a to the 4th. Negative 3b to the 7th is negative 2187b to the 7th. Multiplying all those numbers together, I get negative 11,547,360, and that is the coefficient that I was looking for, the number in front of the a to the 4th, b to the 7th term. One more, last example. Okay, find the coefficient of the term that has a to the 6th, b to the 5th in it, coming from this expansion. Well, I know the r is 5. Okay, and n is 11. So when n is 11 and r is 5, I put that all together in here. I got 11c5, x to the 6th, 11 minus 5 is 6, and y to the 5th. And putting 2a for x and negative 5b for y, I get this. Putting my exponents on, and 11 to the 5th. 11c5 is 462. 2 to the 6th power is 64. Negative 5 to the 5th power is negative 3125. Multiplying all those numbers together, I get negative 92,400,000, and that was the number that I was looking for. That's the coefficient, the number in front of the eighth, the sixth, 5, b to the fifth. Here's your Google form, your first Google question. Find the binomial indicated binomial coefficient. What is that? Number 2, find the indicated binomial coefficient. What is that? 3, expand the binomial. Expand this. Which one of those expands is the expansion of this? Number 4, find the third term, just the third one. You don't have to expand the whole thing, just the third one. Which one of these is the third term for this binomial expansion? Number 5, what is the fourth term for this binomial expansion? And last, find the coefficient of the term that has a to the third b squared in it from this binomial expansion, and those are the choices that you have. Okay, that's it.